Algebra 2 students. This week we are going to continue solving quadratic equations, but we're going to use a couple different methods. We are going to first use the square root property, and then we are going to solve quadratic equations by doing something we call completing the square. Okay, so we'll separate this into a few different videos so you can chunk these skills. Okay, so first thing I'd like us to do together is to solve these two equations. Now we haven't talked specifically in this class about how to solve this, okay, but most of you know already that the opposite of squaring is square root. So if we take the square root of each side, we have x equal to, and square root of 25 is 5. But we also have to remember that the square root of 25 isn't just positive 5, it's also negative 5. Because when we square negative 5 times negative 5 is positive 25. So what we do in order to account for that in our solution is we write this plus minus symbol in front of the 5. And that way it's a shortcut for us to write positive 5 and negative 5, okay? So instead of doing that, what we do is this. Now, I would not mark you wrong if you separated it, but as we continue on through our different methods of solving, you're going to have to start writing it in this form, so you may as well start practicing now. Okay, let's look at the one on the right. Here we have a perfect square trinomial in its factored form. And just like before, we have something being squared. So the same concept applies. We can take the square root of each side, and the inverse of squaring is square root. So by doing that, okay, I'm left with on the left-hand side x plus 3, and that equals plus or minus 5. Now if I keep going, I have to get x alone. I would subtract 3 from both sides. And what I have here is negative 3 plus or minus 5. I'm going to keep going with this and solve this to find out what my two zeros are. And to keep going with this, what I need to do is negative 3 plus 5. So I'm going to solve it once by doing the negative 3 plus 5. And negative 3 plus 5 is positive 2. Or I'm going to solve it down below. Negative 3 minus 5 is negative 8. So I have two solutions. 2 and negative 8 are the two zeros of this quadratic. Okay. Let's do a few more of these together. And this time we will factor and then we'll apply the rules, okay? So we're going to have a little bit more work. They're not just going to be set up for us right away. Okay, the first one, it says 4x squared plus 11 equals 59. Well, typically I set all my quadratics equal to 0 if I'm going to factor them. But in this case, I'm noticing there's no b term, there's no x term. So I think what I might try doing is subtracting 11 from each side. And the reason I'm thinking this might be a good idea is because I know that 4x squared is a perfect square, and I can take the square root of that. So I think if I can gather all of my constants on one side, then I can just deal with square roots after that. So 4x squared equals 48. Now I can take the square root of 4, but I can also divide both sides by 4. That seems like a good idea, because then I'll have smaller numbers. X squared equals 12. And now the x squared is isolated, so I'm going to take the square root of both sides. X is equal to plus or minus the square root of 12. And this answer is okay. It's not great. We're going to use our skills that we learned the very first week of the school year to simplify this. So remember from that time, we ask ourselves what perfect squares go into 12. Well, I know that 4 times 3 is equal to 12, and 4 is a perfect square. So I'm going to simplify my answer to be x equals plus or minus the square root of 4 is 2, and then the square root of 3 remains as it is. So this is the best answer. Let's do a few more. Okay, let's take a look at it first. This looks like something I can factor. I also noticed that there is a 49 on the right-hand side, and 49 is a perfect square. I can take the square root of that. So I think what I'm going to do is ask myself what multiplies to 16 and adds to 8. You're right, 4 and 4. So I can write this as a perfect square trinomial, okay, in factored form, that equals 49. Now I can take the square root of both sides, and I'm left with x plus 4 equals plus or minus 7. Subtract 4 from each side. X equals negative 4 plus or minus 7. Now remember, we want to keep going and simplify this. If all we have are whole numbers, you need to keep going with it. Now if you end up with some kind of messy, awful fraction situation, then you can just leave it similar to this. So we're going to start by doing negative 4 plus 7. That's 7 minus 4, which is 3. And then we'll go negative 4 minus 7, which is negative 11. And again, that's not hard. All right, one more of these. Okay, so I see something that looks like I can factor. Let's see here. 36, what multiplies to 36 and adds to 12? That would be 6 and 6, so I can write it as x plus 6, quantity squared. The unfortunate thing is 28 is not a perfect square. So basically we're putting these two problems together. The top one where we had to do some simplifying with our radical, and the second one where we had to first factor and then take square roots. But that's okay. We're in Algebra 2 Accelerated because we like math, and so we're going to just do a little bit more math in this one problem. All right, x plus 6 equals plus or minus the square root of 28. I'm going to need to isolate the x, so I'll minus 6 from both sides. X equals negative 6 plus or minus the square root of 28. Now I'm going to try to simplify my radical. Are there any perfect squares that go into 28? Yeah, 4 times 7 is 28. Right? All of a sudden I'm having second thoughts. No, 4 times 7. Yeah, that's 28. So to write this out, I will have negative 6 plus or minus 2, because the square root of 4 is 2, square root 7. Now I can stop. I'm not going to actually add and subtract. When I have that radical there, I can just leave it. This is considered simplified at this point. Okay, we're going to take a pause here, and when we come back, we're going to look at some more ways of applying this method to some problems that look a little different.